I wanted to go ahead and do a quick review here of inverse functions. Whoops, sorry about that. Before talking about the derivatives of inverse trig functions. We're going to focus on the inverse trig functions first because this is more a matter of memorization than dealing with just inverse functions in general. So if we think about what a trig function is doing, we're saying f of x equals sine of x. It means that we're putting an angle in for x, and it puts out a ratio. So for example, if I put in pi over 4, I get out the ratio rad 2 to 2. Okay. The inverse of that reverses the process. I put in a ratio, I should say this is the sine of pi over 4. I put in a ratio, it puts out an angle. So when you see this little -1 superscript, this is not sine to the negative first. This is not sine -1. We say inverse sine. You could also see arc sine. There's some differences between the two in terms of one of those is the relation when we graph it. Specifically, arc sine is the relation going on for a range of all real numbers, whereas inverse sine with that -1 superscript is a function. On the AP exam, they tend to use inverse sine and arc sine interchangeably, so you have to kind of be comfortable with seeing either one of those. The reason they'll use them interchangeably is they'll always restrict the domain on these to make sure that whether they're saying inverse sine or arc sine, it's still a function. But the idea of the inverse trig function is you put in a ratio, it tells you what angle that's for. So when we see the inverse sine of rad 2 over 2, what we're being asked is what angle has that ratio, and that would be pi over 4. Now, the derivatives of the inverse trig functions. I could go ahead and show you where these come from and all of that, but quite honestly, nobody remembers that. Everybody just memorizes the derivatives of the inverse trig functions. And this is one of those things that they don't come up often, so you kind of memorize them for the AP exam and then you promptly forget them. Or in this unit, you'll memorize them for our unit test and then you'll promptly forget them. And then I'll tell you, hey, there's going to be an inverse trig derivative on a review quiz. You'll memorize it for the review quiz, and then as soon as the review quiz is done, you'll forget it. You're not going to hear me say this often, but that's okay. They just don't happen often, and it's one of those you memorize it when you know it's coming. So derivative of inverse sine is 1 over the square root of 1 minus x squared. Please note that this x is whatever I have here, because chain rule may be involved. So whatever I'm taking the inverse sine of is what's being squared inside that radical in the denominator. Derivative of inverse tangent of x is 1 over x squared plus 1. And again, this x, whatever is in there, is what's being squared here. And the derivative of inverse secant of x is 1 over the absolute value of x times the square root of x squared minus 1. That's the really annoying one. Now, if we look at the inverse cosine, inverse cotangent, inverse cosecant, you'll notice it's the same things. They're just the negatives of the non-co. So this is very similar to when I said, hey, it's very helpful to memorize the trig derivatives. There are shortcuts to this. If you know inverse sine, inverse tangent, inverse secant, you just make them negative and you have derivative of inverse cosine, inverse cotangent, inverse cosecant. Examples of these. Let's say I have the inverse sine of x squared and I want its derivative. I do need to worry about doing the chain rule because inverse sine is a function and x squared is inside of it. So doing the chain rule, I take the derivative of inverse sine, which is 1 over the square root of 1 minus whatever's inside of it, squared, times the derivative of the inside. There's my derivative for inverse sine of x squared. If I have the inverse cotangent of the square root of x, well, remember, radicals are not very friendly in calculus. So I'm going to rewrite this as the inverse cotangent of x to the 1/2. So the derivative of that is going to be negative because it's 1 over what's inside x to the 1/2 squared plus 1. And there's the derivative.